welcome back to my YouTube channel. Today we are going to learn how to do logic gates. Right, what is a logic gate? A logic gate is a gate that provides a binary algebra function. What are they? The binary basic functions are AND, or not. What are they? They are, that's correct, AND, or not. These can be expressed as pictograms. So AND being a D because of the D there, or being the curve of this O, or not being a circle or triangular circle. These allow you to get operations. Now first, before we get into the pictograms, we must understand what a truth table is. A truth table is a table that we can use to find out all the possible outcomes. What outcomes? All of them. I will do one for the basic operation AND. Let's have an AND operation. We can draw a truth table by putting the inputs A and B and getting the result Q. Now, before we understand what these things mean, we must look at the diagram. The pictogram of an AND looks like this. Our input here is A and here is B. We input two variables. How many variables do we input? That's correct. Two variables. And we'll get something out. Now these are of course in binary. So let's put these in now. A shall be 0, then 1, and then 0 and 1 again. And when B is 0 and 0, A will alternate, and when B is 1 and 1, they will alternate. And suddenly you have all the possible solutions. Now, for AND gate, an AND gate only outputs a result Q when both A and B are on. So we have both A and B on, so this one will be on. The rest of them will be off. Why? Because the other input is not on. So this is off and off. And this is how the truth table works. You can now use this for all of your operations. I am going to give you the next table, OR, and I want you to solve it yourself. If you look at the board, I have written the standard operation OR and NOT. I want you now to fill in the solutions to the truth table. I will give you a hint. OR will always output unless both inputs are 0. And NOT will give you the opposite output. Please take 2 minutes to fill in this table. Now that you have finished, I shall give you the answers, starting with the standard operation NOT. 0 will go to 1, and 1 will go to 0. This one is pretty easy. Now let's go to OR. 0 and 0 is the only operation which will give you 0. Everything else will give you 1, 1, and 1. This one is now also pretty easy. There is also one more difficult operation called XOR. XOR as in XOR. We shall now go on to XOR. Now we are going to talk about the XOR function. The XOR function, or XOR, is also known as the inequality function. I am going to draw the truth table. This is a very hard truth table. We have the input A, B, and the output Q. Very similar to our AND OR operation. Now if you want to look at here, we have 0, 0, 0, 1, 1, 1, 0, 1. XOR is a very important function. See, if both inputs are the same, it will provide a 0 output. So 0 and 0 are the same. 1 and 1 are the same. However, the opposites will provide a 1 output. What is this? If the output is not the same, then it will provide a 0. Okay. Now how did we get to XOR? XOR is actually a combination of all of these functions. These are a form of a NOT AND, which is added to the OR. This is a complicated function, but this is very useful in advanced computer science. I am going to now draw the function. We have our starting input A and our starting input B. We are then going to take the addition and the NOT and the inverse of the addition of both A and B. After this, we are going to take the OR function. What is this? We are going to take the standard operation OR of A and B. So we shall now draw this in. Once we get the output of this, we shall now AND the operation. This will give you your answer Q. As you can see, this is a very complicated function, and you can see it uses all of our states, all of our standard operation, and OR and NOT. In a moment now, I am going to draw out the full truth table, and I am going to ask you to complete it slowly with my guidance. Before we get into the truth table, we are going to run into a very big problem. When we try to do functions like XOR and NOT, NAND and XOR and XNAND, there is going to be a very big lag time in writing out the functions. So there was something developed called Boolean algebra. Boolean algebra states that there is a shorthand method for writing all of your functions, and can be written or subscripted by a dot. So you can have A dot B gives you your output Q, or can be subscripted by a plus. A plus B gives you your output Q. The last one is NOT. NOT is special. Thanks to the physicists, we have an automatic thing called a top bar. The top bar is applied to the function to give you your answer Q. So remember, AND is dot, OR is plus, and NOT is the subscript bar. Now that we know how to use Boolean algebra, we shall now take this and put it into an algebraic form. We have our inputs A, B, and our output Q. So we see that A and B, they go into a NAND gate, then into the OR gate, and the outputs of both are added. Let's try to write this out. First, we shall start with a NAND. A NAND is written as A and B subscript the entire solution. We can actually put brackets around it to make it easier for some of you. Then we shall do the OR. The OR is A plus B. Now we must add them together. So we shall put brackets around it to make it easier for us to understand, and put the full stop. And this is known as the XOR gate. XOR gate. But how do we check this is true? We can check this is true by doing the table manually. This is very difficult, so I am going to do it along with you. Let's start with our inputs. A 0 0 1 1 0 1 0 1. This gives us all possible combinations. Now A and B. This goes to 0 1 0 1 0, which is 0. And these two give you 1. This is to do the inside of the bracket. Now we shall do the not or the inverse. Inverse gives you 1, 1, 1, 0. Very simple. Now we shall go to the OR gate. Now OR gate, as we know, the first one 0, 0 will give you 0. Everything else will give you a positive. 1, 1, 1. Now we shall AND the gates together, the OR and the NAND. 1 plus 0, or 1 and multiplied by 0 is 0. 1 and 1 gives you 1, 1 and 1 gives you 1, and 1 and 0 gives you 0. And now we can see when we go back to the original, A, B, 0, 0 gives you 0. 1, 0, 1, 1. 1, 0, 0. 1, 1, 0. And just like that, we have completed the Zohr truth table. In your exam, you may get something else in this form. You can follow the same steps that we used to calculate the Zohr table for any Boolean algebra statement. You can use this to check your answers or do the question. Now that we have understood the Zohr, you can now go on to other videos and figure out how to do half adders. Thank you for watching this episode of Computer Science with me, Dr. Rajesh. I will see you guys in the next episode. Thank you, and remember to like and subscribe. It really helps the channel.
There's 3 types of gates. There's NAND. Okay, looks like this. It's essentially the reverse of AND. So anything that you see in AND gate, it's the opposite. Okay, now that's the NAND gate. It's very useful in flash memory. Yeah. Okay, moving on. This is the NOR. This is the NOR gate. It looks like this. Okay. It's essentially the reverse of OR. That's what it looks like. So the Zohr gate is that if they're different, then they'll be 1. So 0 and 0 are 1. 0 and 1 are 0 and 0. And 1 and 1 is 1.
Excuse me, my friend. There is one problem with
Who are you?
I am Mr. Dr. Rajesh. As you can see, the Zohr gate is actually the opposite of what you have. What is it? The opposite. Correct. It is 0, 1, 1, 0. It only gives you one output when they are not the same. Because it's XOR. What is it?
Why the door?
It's XOR. Correct. Thank you. To like and subscribe. It really helps the channel.